In this video, we're going to discuss CRA models for partitive or fair sharing whole number division. So there's two different ways that we can conceptualize whole number division. We're just going to talk about the first type in this video, so that's the partitive or the fair sharing. So this is where our dividend, the total, that's always our first amount, and it's saying we're dividing by, and then our divisor. So with this fair sharing division, we're saying that the divisor is telling us the number of groups that this total is being divided into. Okay, so we're going to start with some total amount and rearrange it according to some number of equal groups. Okay, so we know what the group number is, how many groups we have, and then our quotient or our answer, what we're looking to find is what is the size of each group or how many objects are in each group. Okay, so we'll get to the measurement division in a future video, but we're just going to do the fair sharing one now. So the first type is going to be a set model. Okay, so for all of these, we're going to be looking at 12 divided by 3. So again, 12, that's saying we have 12 objects. 3, we want to divide these into 3 equal groups, and what we're trying to find out is what is the size of each group. Obviously, we know it's 4 since I already wrote it down, but so again, set model, we're just counting the total number of objects. We're not measuring any dimensions. So here we have 12 counters. You can just use any sort of object for this, for the concrete model. If I want to divide this into 3 groups, let's say I don't know that it's actually 4, kind of the process that students would move through is I'll just have one group over here, one group in the middle, and then one group kind of on the far right. So I'll put one counter into each group. Okay, so that's kind of the first step or first stage. Okay, so I need to keep these groups equal with each step or stage that I go through. So I'll put a second counter into each group, and then a third, and then a fourth, and then I don't have any of my original quantity that it hasn't been placed into a group. So this is showing that we can start with 12 objects, divide them into 3 equal groups, and we will have a size of 4 in each group. Okay, so that's concrete for the set model. For the representational model, we'd probably do something similar, but since we're not able to actually move these around, we'd probably cross them off. So I'm just going to have 12 circles there. And again, if I have 12 circles, I want to subdivide these into 3 equal groups. So again, the first step, so I'll go here, and we just kind of cross these off. And we'll put a second one into each equal group, third, and then fourth. Okay, so then all of those have been crossed off, so that means I've taken all 12 of those, placed those into 3 equal groups. Each has a group size of 4, so I know that's my quotient or my answer. Okay, and then that 12 divided by 3, that will be 12 divided by 3 equals 4. That will be the abstract model, again, making connections from the models and what they mean as far as groups and size in relation to where our values show up, whether it's the dividend, divisor, or the quotient. Okay, so that's the set model. Next, we'll look at the length model. So we can use connecting cubes. I just use normal cubes because it'll be easier to slide around for me. But again, length model, we're measuring one dimension, so we have the length. So this is the total length, right? That's our 12, the total length there. And we want to subdivide this or divide this or separate this into 3 equal groups. Okay. So again, if we didn't know that it was going to be 4, right? All we know is that there's going to be 3 equal groups. So again, we I'll try to leave enough room here. Actually, I'm going to offset this a little bit so we can just to make sure they don't overlap. So these will be my 3 lengths here. Okay. So again, we're taking 1, we're keeping all the groups equal. So since we still have some amount left from that original quantity of 12, we need to keep doing this. And again, since it's a length model, we won't want any gaps in here since we want to show there's an actual length. Okay, so the second one. And then third, and then finally we'll take Put a fourth into each group. So here we can see, and then we don't have any amount left, so that's how we know that we're done. All right. And here we can see there's 3 separate groups that each have a length of 4. Okay, so that's our concrete length model. And again, any kind of unit where we can measure length where it's all uniform units can be used for those. The representational one's going to be a little bit trickier for this, probably not as commonly used. But we'll just use a length or a number line. We'll kind of see why this might not be the most commonly used route, but we're just going to show kind of one. Actually, I want to show, rather than one big jump of 12, I'm going to show 12 small jumps so we can kind of keep track a little bit better. Okay, so each of these jumps has a length of 1. So we have this total length of 12 here. Again, we want to divide this into 3 equal groups. Since we're just going to pull these out one at a time, right, we're going to have to kind of think of putting this on 3 separate number lines, which might not be the most efficient type of model to use here, so it might not be quite as common, but I'll still show you nevertheless. So again, since I want to have 3 equal groups, I'm going to show kind of 3 different lengths here, or 3 different number lines. Okay, so again, I'll take these first 3 hops, or lengths of 1, and I'll put a length of 1 into each of the 3 groups, and then we'll just do that same process. Take a second one, a third for each of the 3 groups. And we have those 3 lengths left, so we'll put a fourth in each. So you can see we have 4, a length of 4. We have 4 hops, length of 4 in each. Okay. So kind of similar to the cubes, just a little bit more tedious. But if we don't have those concrete tools, this is something that we can still kind of follow that same structure. And then again, the abstract model will be actually writing out with numbers and symbols of 12 divided by 3 equals 4. Again, making connections to 12 is that total starting amount, and 3 means we're going to have 3 equal groups. We're trying to find the size of each group, which ends up being 4. So then we'll look at the area model. Okay, so again, 12 divided by 3. So in the context of an area model, that means I have 12 square units. Right, so we just have 12 square units. I don't have them arranged as an area model right now because we need to kind of figure that out as far as what the structure of this is going to be. Okay, so 12 divided by 3 means I'm going to have, if we're doing that partitive or fair sharing division, the 3 is telling me that is the number of groups that I'm going to have. And I want to figure out what is the size of each group. Okay. So again, for an area model, we can think of that group as being either rows or columns. I'm going to just show this for rows. But so this is my starting amount of 12 square units. All right, let me scoot this over a little bit so it's not in the way. So I'm going to interpret that groups as rows. So I want to create from these 12 square units an area model that has 3 rows, and I want to figure out what's the size of each row. So then we'll take 3. Right, so here I have 3 rows that have a size of 1, and then I'll keep building onto this model until I run out of cubes. Okay, so 3 rows that have size of 2, 3 rows that have a size of 3, and now 3 rows that have a size of 4. Okay. So there we can see from those 12 square units, if we divide that into 3 equal rows, each row will have a size of 4. Okay. So that's concrete area model. For the representational model, I'll draw these real quick. Okay, so I have 12 square units, and I want to arrange this into an area model, and we want to have 3 groups, and again, I'm just going to do rows as the groups. Okay, so again, it's going to follow the exact same process, but we just don't have the cubes, the physical pieces to slide around. Have that concrete tool. So we'll just have to do 3 rows that have a size of 1. So I've taken 3 of those square units and arranged them in that row structure. I'll take 3 more. So there's 3 more. Because I have 6 left, so I'll do another. Add another tile to each of those rows, and I have 3 rows of 3. Okay, and then I have these 3 remaining. So then 3 rows of 4. Okay. And then again, 12 divided by 3, that's going to be the abstract model. 12 is the total number of square units that we have here. And then 3, how I showed this was we're interpreting 3 as the number of rows that we have. Okay, so we're saying that the groups are showing up as rows in the model. And again, if we wanted to say, well, the groups of the columns, it would all look the exact same. Everything would just be rotated 90 degrees, right? 3 columns that have a size of 4. Okay. All right, so that's the area model, and then our last one is going to be the array model. All right, so in our array model, again, this is kind of the union of a set model and an area model. So it's a set model that's going to be arranged in that row and column structure. So 12 divided by 3, we have 12 objects. Again, 3 is the number of groups. I'll show the columns actually this time. We'll interpret groups as being columns. Okay, so we want to have these 12 counters, and we want to arrange these in a way that there's 3 columns, and we're going to figure out what is the size of each column. Okay. So I'm going to move these over just they're out of the way for now. Okay, so I'll say I have 3 columns. Okay, so that's 3 columns that each have a size of 1. Okay, and then 3 columns that have a size of 2. 3 columns that have a size of 3. And then 3 columns that have a size of 4. Okay, so same sort of idea as the area model, but here you can see we have gaps. We're not actually measuring the area, we're counting how many counters there are here. Okay, so that's the concrete model, and again, you can use any sort of object that we can just arrange in that row and column structure. Okay, now I'll show the drawing real quick. I'll do the same orientation. So I have 12 circles, going to arrange these so that I have 3 columns. I'm going to figure out what is the size of each column. Okay, so I have 3 columns, each have a size of 1. Cross those out. Now my 3 columns have a size of 2. I've taken those 3 and placed those there. I'll take these next 3. So 3 columns have a size of 3. And then the last 3 here. Alright, so 3 columns that have a size of 4. Okay, and then again, the abstract model, 12 divided by 3 equals 4. Again, making connections to that groups and then the size of each group. And again, that for the array model, similar to the area model, the groups, we can think of that as being either the rows or the columns. Both of those cases would work.